Hello everyone, welcome back to the solutions for the BSDS sample paper 2024. Now we have solved quite a lot of questions. We are nearing towards the end of the paper. There are 31 questions in total and we are at question 20 now. Alright, so question 20 is a play on functions and limits continued differentiability. All of the concepts are bundled into one question, which is very neat. So the question says a function is defined from the open interval minus pi to real numbers. Alright, it's defined as 0 if x is 0, so the function is defined at 0. Alright, because otherwise the function is x cubed by sine square x, which is undefined at 0, right? Because sine 0 is 0 and you cannot make that division. It's a 0 by 0 form. So overall, the way the function is defined, this function is continuous at 0 and therefore differentiable. Alright, so what is the answer that they want? They want the number of points of discontinuity and non-differentiability. Alright, so usually we want the number of points where it's continuous and differentiable, but here it's the reverse. Okay, so please look through the wording of the question before you start working on it. Now, where will this function start to throw up problems? It will throw up problems at 0 for continuity, but since the function is well defined at 0, it will be continuous at 0 and it will be differentiable. Now, where are the other points where it will be not existing and not differentiable? So that list will be discontinuous. At 0 it's fine, well managed, but otherwise it will be discontinuous at x equal to k pi, where k belongs to integers, right? Now the case with 0 has been taken care of in the definition of the function itself. So the first values of k would be either minus pi or plus pi, right? But as you can see, that value does not exist in the domain, right? So the function is discontinuous at points which are not in the domain because the domain is minus pi to pi open. And here we are getting the first discontinuities with respect to the function definition at 0, which is covered in the function. Then it will be minus pi and plus pi. Minus pi and plus pi are not in the definition of the function, so there are no discontinuity points as of now. Alright, so from this first criteria we do not get any actionable discontinuous points. Now from the second way in which we will see if it's not differentiable somewhere. Now if it is continuous and well defined at 0, then it's differentiable at 0. Alright, now are there some other points where this function might go to 0? The answer is no on the basis of the function. But are there any points where its derivative might go to 0? That will be yes, because you have sine square x in the denominator, so if you try to differentiate it, you will get at least one term of cos x, right? Now when you get one term of cos x, it will always be 0 at 90, right? Cos 90 is 0, sin 0 was 0, but cos 90 was 0, so we have to take care of that term as well. Now what are those cosine terms? They are nothing but critical points on the graph of sin x, where they are also called points of inflection, right? Where the graph turns. So that turn should be smooth, otherwise it won't be continuous and it won't be differentiable as well. So we have to take care of those points as well. So what are those points? Those points are x equal to pi by 2 plus minus k pi, right? So non-differentiable at, let me write it out for you, x equal to k pi plus minus pi by 2 as well, k belongs to z. Now let us check the case of just a minute, I made a small mistake. It will be pi by 2 plus minus k pi, right? Because that is fixed. The phases at which it will be 0 are pi by 2s, right? Because cos pi by 2 is 0, and then this will vary, plus minus k pi. Okay, so small mistake in writing. That's why I was thinking why I have getting more points. Alright, so now when we have pi by 2 plus minus k pi, so at k equals to 0, this is just pi by 2, so we have one non-differentiable point. Alright, at k equal to 1, we either have pi plus pi by 2 or pi by 2 minus pi, right? So it will be pi by 2 minus pi, which is minus pi by 2. Now cos is an even function, so the value of minus pi by 2 as well as the value of plus pi by 2 will both be 0, right? But even then we get a few more points of non-differentiability, right? So what are these points? Let us list them. K equal to 0 gives us, we have x equal to pi by 2. For k equal to 1, we have x equal to 3 pi by 2 and minus pi by 2. Now, I hope you can notice the problem with this 3 pi by 2. 3 pi by 2 is again outside the domain, right? Because it's more than pi. But this one remains. Minus pi by 2 is there, right? So we can have two non-differentiable points at plus pi by 2 and minus pi by 2. Plus pi by 2 is gotten from k equal to 0 and minus pi by 2 is gotten from k equal to 1. Now why are you not testing 2, 3, etc.? Because whatever value you put will go out of the domain, right? Because at k equal to 2, we will either have 5 pi by 2 or minus 3 pi by 2. Both of them are beyond the reach of the domain, alright? So that is why we will take only these two values. Therefore, k is the number of points of discontinuity. So what will be the value of k? K is 0, right? There are no discontinuous points here. Now what is the number of points at which it is not differentiable? So this will be 2. Now L is equal to 2 because I have the values pi by 2 and, okay, let me remove this bracket because otherwise it will appear as a range, at pi by 2 and minus pi by 2. Alright? I hope you could understand it, because as soon as I differentiate the denominator, I will be getting 2 sin x and then cos x, right? If that cos x becomes 0, then the entire denominator will become 0. Okay? So I have to take care of the zeros of cos x as well, because those are the critical points for sin x and there the graph is turning. Okay? So k is 0 and L is 2, which is the option that we have here. None of them, right? Because L will be 2 points of differentiability, so I'll mark option D. Okay? I hope you could understand it. If not, please do rewind and rewatch the video. And do let me know if you have any problems related to this. If you have any suggestions, like you have already put some comments in the previous videos, I have gone through them, and wherever some corrections or explanations are necessary, I have remade some of the videos and they will be going live soon. So you can look into them. Alright? So keep up your engagements in the videos. I will be sure to look through them. And if you have any problems, any help that you need, do look through the numbers that are given in the comment section. You can reach out for help there. Okay?